Good morning, everyone. My name is Daniel Melling. I'm the Director of Marketing and Communications at CTrees, and I'm very happy to welcome you to our webinar today, Measuring What Matters, MRV for High Integrity Jurisdictional REDD. This is our second webinar of the year, following our webinar on above ground biomass in April. And we're really happy to welcome you to discuss this important issue. Uh, Today we have three speakers: Ricardo Dalagnol, our Activity Data Science Lead; Adugna Mullissa, our Radar Science Lead; and Raymond Song, our Carbon Markets and Policy Lead. This webinar will be 1 hour. We are recording, and we will post the recording to YouTube, and we'll also be happy to share the slides after the webinar with you all. There is a Q&A function, so please use the box to share your questions. We'll be responding live to some of them, and we'll also have a portion of the webinar reserved for Q&A after the presentations. I wanted to share a little bit about CTrees. We are a nonprofit based in Pasadena, California. Our mission is to track carbon in every living tree on Earth to accelerate nature-based climate solutions. We are really centered in science and research and development. Our science team of more than 25 scientists, engineers, and policy experts publish regularly in leading scientific journals and conduct research and innovation to build next generation data sets for tracking biomass, tree canopies, and forest activity. In addition to this research and innovation, we pursue applications and develop data solutions for policy and markets. Today's agenda, we're going to be covering the jurisdictional REDD market and give a brief update on where things stand. We'll then be going into CTrees' scientific approach, jurisdictional REDD MRV, and then we'll be sharing a few examples of due diligence in practice. We'll share a little bit of our big picture of how data fits within the jurisdictional REDD market, and then we'll be transitioning to the audience Q&A. So I'll now hand it over to Raymond Song to share a little bit about the jurisdictional REDD market.
Thank you, Daniel, and great to see everyone. So let me start with where the market is today, because it's come a long way fast in recent years. There are now 40 plus unique jurisdictional programs across different methodologies, from FCPF to JNR to CTrees, and that we anticipate that the supply in the pipeline will increase to 300 million tons of CO2 equivalent by 2030. And that will hopefully generate over $4.5 billion annually from jurisdictional REDD Plus market by 2030, and that we anticipate high integrity JREDD price to increase to a price band from $15 to $23 per ton. And looking ahead to the next few months, we see several jurisdictions very close to issuance following their validation and verification process. Congratulations to Costa Rica for their great news today in going through that process and making the issuance under the CTrees methodology, and that we see jurisdictional programs methodologies converging to new CCP-aligned, ICVCM CCP-aligned standards, such as JNR and CTrees, and that the Forest Climate Leaders Partnership has established a new JREDD Plus alliance across multiple actors to accelerate JREDD progress on the ground. And finally, we see compliance demand from CORSIA market and the maturing of the Paris Agreement crediting mechanism, mobilizing new demand across jurisdictions. Why jurisdiction? Why now? So first, if you cover a whole jurisdiction at scale, deforestation will not easily leak across boundary and vanish, from one area to another. And second, the durability is built on national and jurisdictional policy frameworks. We hopefully the reductions will be more permanent. And then, the jurisdictional program will also connect straight to opportunities to eliminate commodity-driven deforestations and link it to landscape-level restoration programs, which matters a lot as rules such as EU deforestation regulation kicks in. And finally, there's an opportunity to align that with the Paris Agreement Article 5, the original REDD framework, and national and jurisdictional policies to protect forests at scale. And if we can scale these jurisdictional programs successfully in the next 5 years, it has an opportunity to generate a total of $8 to $15 billion dollars for all tropical countries from now till 2030. So on the CTrees, so this is where credible solutions from CTrees come in. So far we've done historical deforestation forest cover for 43 jurisdictions under Verra's VM48 methodology. This is the data behind credible scientific independent forest benchmark and risk map. And we've run independent due diligence for CTrees and FCPF JREDD programs across 9 jurisdictions. And we believe that this independent scientific solution is the key to monitoring forest activity, biomass, and tree canopies across tropical forest countries. So zooming in on our unique solutions, this is 4 capabilities across an end-to-end workflow. First, we attribute activities across deforestation, degradation, and crucially, natural regrowth from these tropical forests on an annual basis. Then we calculate the emissions and emission reductions through spatially explicit emission factors. Then from our experts, we validate these estimates from satellite data with a sample-based estimate. And finally, once we monitor these numbers on an annual basis, we also track on a more near real-time basis deforestation and degradation across these jurisdictions. And more importantly, you will hear from our scientists how we compare our independent data with jurisdictional definitions and jurisdictions' own data so that we can have interoperability and comparability across the data sets. With that, I'll hand it over to our scientist, Ricardo, to give you a deep dive on our scientific approach.
Thank you, Raymond. So following those opportunities on JREDD, now we are going to go through some of the technical considerations for robust digital MRV based on lessons learned from actually building data sets for baselines and doing due diligence over 9 different jurisdictions. So starting off, we find it's very important that establishing an accurate forest baseline. So forest cover maps are more well-tuned across the tropics over wet forests. However, when we go for dry forests, such as this, that can be landscapes like in Ethiopia, we find that doing careful calibration is needed to achieve good forest cover and also then deforestation maps. So as you can see here, these examples show an area in Ethiopia. As you can see the Google image in very high resolution, and different data sets, they may map different areas as forest cover. And as you calibrate and you improve your maps, you may cover them better. And so you have the opportunity to then map those areas as deforestation. So that's the first key point, calibrating data set for the jurisdiction you are analyzing. And then as well as that on that forest baseline, another extremely important component that we found over our study case in East Kalimantan in Indonesia was that 49% of our forest change that was mapped between 2001 and 2025 was located in areas of previous forest plantations. So forest plantations are very common in Asia, and they are not something totally new, right? They already exist for a couple of decades or hundreds of years. So having an accurate baseline before you start assigning deforestation is key to not confuse what is just management activities to what is deforestation. So that is part of the data and our approach. Then a third component is differentiating and attributing deforestation and degradation. This is a huge discussion, scientific-wise community. However, when we go to practice, we want to say over this area that burned in state of Pará, for example, in Brazil, was it completely, the tree cover completely lost and it's now deforested, should be put in the bucket of deforestation or degradation. Especially for these last years, such as 2024, like there was record-breaking fires, it's very difficult to map and it's very challenging to attribute this automatically. But we must use our judgment in some cases and adjust the data sets so we produce the best assessment possible. So open data sets show a spatial agreement across the board around 30 to 60% on what forests are being affected, are changing. However, the attribution is highly varied. As you can see, like from TMF dataset and GFC dataset, those are great data sets to assess forest change in the tropics. However, they may differ in terms of attribution. And our role here is when we do an assessment to have confidence to say, okay, this area is actually just burned, it's fire degradation, it's not yet at deforestation stage. And then another example that I bring for this is shifting agriculture or shifting cultivation. So in Africa, Central Africa, like as in Chopo in DRC, these areas are experiencing small clearings that are in fact deforestation, that are then followed by agricultural practices, and then they may regrow to forest, naturally regrow, or they now have some kind of agroforestry system. So they may be perceived as a regrowth, right? They will be perceived as regrowth, a lot of them. However, we must, in this case, say, okay, this is actually deforestation being followed by a regrowth and attribute correctly. A fourth component is around minimum mapping units. And every country, every jurisdiction will have a different one. It may follow the forest definition of that country, let's say 0.5 hectare. However, an example from Brazil, for example, you see the PRODES data, which is the base data from official data from Brazil, uses a 6.25 minimum mapping unit. So it's much larger than the forest definition. That's a historical technical limitation, because initially in the 90s they were doing that on paper, right? That was the minimum resolution they could get it. But with digital environments now, we can get as close as to the pixel level or to the forest definition, right? So by using larger minimum mapping units to assess deforestation, you can underestimate deforestation in 12%, as this example in state of Pará. So these areas in magenta in this image, you're going to be losing them because they do not yet reach that minimum mapping unit. And that also affects, it adds delay to detection. Because whenever the deforestation is occur, it's small, it takes a few years for it to progressively increase and reach that minimum mapping unit. So we did an assessment over Pará, and we found that that average delay was 3.5 years. So that has an important effect for carbon emission reductions when we analyze these reports. So we must think about what kind of like source of discrepancy we can find, right? This is the back question for all of these assessments. So we see that if we use the raw deforestation values, that column, we find a 61% reduction in deforestation from reference period to monitoring in Pará, which is great, like it's reducing deforestation. But when we do a simulation, increasing that minimum mapping unit to the 6.25, we found that that reduction is bigger. So is it bigger? Is that true? What is happening here? This is just an artifact of the minimum mapping unit. if you look at the rows, you're going to see that in the reference period, the minimum mapping unit effect was 2.5% reduction, whereas in the monitoring, it was 11%. So it had a different effect in the reference and in the monitoring, causing a larger emission reduction. This will be found especially in jurisdictions where you have smaller deforestation that grows over time, and especially in the monitoring period, right? The last few years where deforestation does not yet have time to expand up to the minimum mapping unit. So this can be a pitfall for assessing these reductions. Another question that we must ask ourselves when we do this assessment, that's what we do in our process, is around the frequency of land cover, forest cover mapping. So often jurisdictions use a case like this. They have maps that have an interval because of limitations of the imagery and technical as well. So this example, 2000 and 2005, both areas are forest, right? However, there was the deforestation happening in the middle of those two periods. But if you use the 5-year interval in this case, you're going to omit that deforestation. So having annual monitoring in this case helps to monitor much better this forest cover loss and the regrowth that happens afterwards. So this is the actual how the data look like in one area in Laos, in Asia, where this deforestation area in the middle in magenta, it will be a great part of it will be omitted if we use a 5-year interval. And then we did an assessment over the entire jurisdiction of Laos, and we found that when we use 5-year interval, we only capture 19% of the total deforestation compared to the annual monitoring. This makes sense to Laos because a recent paper found that 87% of total deforestation in Laos was associated with shifting cultivation, areas that are deforested and they regrow. And we analyzed it, this 3.2 is actually our number. We analyzed that the forest regeneration time was 3.2 years. So when the satellite looks at this area, it gets deforested, on average, it's taking 3.2 years for it to be perceived again as a forest. So if you don't use annual monitoring in this jurisdiction or similar jurisdiction, you're going to be omitting a lot of deforestation. Then a next point is around fire degradation. What we find is that it's very important to combine data sets to better represent fire degradation. This study case shows Mato Grosso in state in Brazil, where DETER is the official data from INPE from Brazil about fire degradation. It's excellent data. It covers the highest burned forest in the state, but still it omits 20% of forest fire. So in this figure, you see the light red is what only DETER maps compared to the other regions. And then also in orange, there are the other non-official data sets from the jurisdiction, such as MODIS data, MCD64, and Mapbioma's fire. They also map those areas, so they help to reduce omission errors. Obviously, there is questions about forest definition, what is still considered a forest for a given jurisdiction, and that plays a role in these assessments. But in this case, in our best judgment, to consider what is a forest at the start of the historical reference period for this assessment, this combination of data sets produce the best result. So that's what we use in our assessments. And then another component related to fires, which is ties directly to the carbon emissions, is the fire recurrence. So repeated fires in state of Mato Grosso represent 74% of the total fires. So areas burn repetitively. So in Amazon biome is less pronounced effect, but in Cerrado it's very severe. So you have areas burning more than 5 times. So this is important when you calculate emission factors, because if you use just a single emission factor, it will encapsulate or aggregate all of these effects. So we believe that using annual emission factors that are specific to the areas being burned or the areas being deforested, and using carbon and AGB numbers for the areas being affected is key for improving these assessments on the year-to-year basis. And the last technical component is about regrowth, which is an overlooked component of the JREDD MRV. Only a few jurisdictions report this, for example, Vietnam and Laos. But it's very important to improve carbon accounting, meaning calculating barrier emission factors. An area that goes into non-forest cropland is different than an area that goes into non-forest and then regenerates, right? So this example over Pará state shows that secondary forests, this regrowth, they already contribute to a lot of areas in the landscape. So we can also use these maps to track the carbon removals in these areas. So going to our JREDD MRV solution, we go back to these points that Raymond introduced to us: attributing activity, calculating emissions, validating estimates, and then monitoring performance. Our assessments are based on our own data set called CIDR, which is the CTrees integrated deforestation, degradation, and regeneration. So it's a forest cover and change data that attributes what is these three processes of deforestation, degradation, regeneration, using our own data set and combining independent data from all the excellent data that exists from other scientific partners to produce the best possible assessment for a given jurisdiction. So we map the large-scale deforestation, forest fires, shifting cultivation, and also logging across the tropics. The current coverage is the wet forests around the pantropical region, but some jurisdictions, such as the states of Brazil, they have already been covered, even though they are dry forest and savanna environments, because of previous collaborations and work we had in the voluntary carbon market. Also recently, we extended over Ethiopia and Zambia and Central Africa. So we are progressively increasing the coverage of our data set. And then having all this data, we also build confidence through expert validation. So we have a map, we distribute samples based on a sample design, and we validate that. So we use time series of imagery, we assess, is this area stable forest or non-forest? Is there any kind of degradation happening here? Or is this going into deforestation? So we attribute this, we calculate accuracies, we calculate area uncertainty. And so far, we have seen consistent accuracy across the diverse forest types we have analyzed across the tropics. Over 44 jurisdictions that we did this analysis, we found 94% forest accuracy, close to 79% deforestation accuracy, and 12% area uncertainty for deforestation. So you can see how the data changes across different jurisdictions. Over dry environments, it's especially challenging, so the uncertainty is a little bit higher, the accuracy is a little bit lower, but this is a good benchmark to show what this kind of data and approaches are capable of. And then second to last on my slides is we use the AGB time series from CTrees that was openly released last month. You can find it online in ctrees.org website. We use those time series of AGB to calculate emission factors on a year-to-year basis, combined with our maps, and calculate those emission factors and apply to calculate the best possible emission estimates for the jurisdictions. And finally, we monitor forest risk. So in between cycles that the jurisdiction or a carbon project is doing their analysis, let's say the start of this year, 2026, how is the project or the jurisdiction doing? You can see in this figure, 2026 is within the baseline. So, okay, I don't need to be very worried about this location. However, if we look back in 2024, it was a very unusual year, like in the Amazon, for example, there was a lot of fire. So that was way above the baseline, right? So we can use these tools to monitor in real time and get confidence and monitor these threats and anticipate the effects before they are happening. So now I hand off to my colleague, Adugna. Thank you.
Thank you, Ricardo. I'll be talking about the due diligence just to show the excellent data sets that Ricardo described in action. So some of you may wonder, like, why do we need like independent JREDD plus due diligence? So as you all know, it's very difficult to assess JREDD plus like submissions in different jurisdictions, because most of them, they have different forest data, definitions, methods, standards, time periods. And unfortunately, to add on top of that, most of the geospatial data attached like to this submission reports is inaccessible. So based on the excellent data that we have, we align specifically to each jurisdiction's definition for that particular submission to make the emission reduction reports comparable and easier to assess. Okay, so the main activity that we do now to align the different standards that we find like in different jurisdiction is what we call by creating the jurisdiction aligned data. So we do this in three main steps. The first thing we do is align the forest definition, what the jurisdiction defines as a forest, and adjust our data based on that definition. So we can see like the same extent of like forest area. The second thing we do is also adjust our activity data, that is our deforestation degradation, to the jurisdiction's minimum mapping unit, and also definition. What I mean definition is how do the jurisdiction define deforestation degradation? So an example to this is some jurisdictions, for example, may consider transition from primary forest into plantation as a deforestation, whereas some others may consider that as a degradation. So accounting for these differences in definition is critical so that we don't underestimate or overestimate our activity numbers. And the third part is our emission factor. So we have to do carbon accounting. So we try to adjust per biome definition of forest and account for transition. That means from forest to non-forest, from forest to agriculture, pasture, and so forth. So our carbon accounting is accurate as possible. So once we do all of these three things, then our data is more or less aligned with the jurisdiction. So it's much easier like to compare and account the emission reduction reports. So once we do that, then finally we provide a confidence rating. So we can ask like a lot of questions here to get the details, but we try to like shrink it down like to these four main questions. That is, do the emission reduction trends align? The answer may be in the affirmative or not. Then we go into like, okay, if it is not aligned, then are the differences explainable or are they unresolved based on the information that's available to us? Then we try to look into the confidence interval. So it's very difficult like to compare like reduction rates like with the low confidence data. So we try to make sure that the confidence intervals are aligned. Then finally, we try to see the evidence that's available to us. Does it support like a robust, uncertain, or potentially overstated reduction claims? So based on this, we put it like on the three confidence spectrum. If we have strong alignment and explainable differences, I say differences here because from experience, no reduction claims that we have seen is identical to our data. So there's always like some differences, but if the difference is scientifically explainable, we put it like at a higher confidence rating. If there is a discrepancy and we can't resolve that discrepancy, that means we need more information. So we put it like on a medium to low scale. If we have ample data and if the discrepancy is clear due to errors or some other reasons, then we put it at a low scale. So to go into elaborate our data like in action, I'm going to be showing like a couple of case studies. The first one is in East Kalimantan, Indonesia. So as you all know, the forest landscape like in East Kalimantan has been under tremendous pressure for the past few decades due to expansion in plantations and logging activity. And to mitigate that, there's been bunch of project level REDD+ projects existing in East Kalimantan, and East Kalimantan also hosts one of the flagship of Indonesia's JREDD JREDD platform. So this is a good example to showcase our data in action. So the first thing we see is we extract the emission reduction numbers from an FCPF report and try to compare the emission reductions claimed and what we see within the crediting years of 2020 and 2021. So we go and ask, like the first question we do, are the emission reduction trends aligned? Yeah, the answer is yes, they are aligned. But the issue here is the magnitude is not the same. We see a lot lower emission reductions than what the jurisdiction is claiming. So to get like a better picture of what is happening here, we plot the emission time series from the start of the historical period until the end of the crediting period. And we can clearly see, based on this emission time series during the historical, that is from 2007 to 2016, the emission trend is more or less aligned. But in the monitoring period, then we suddenly see a sudden spike in emission into more than 80 megatons. And at the start of the crediting period, it drops down to about 2 megatons. So this high and low fluctuations is an issue we have to resolve. We don't understand it at this time. So we go into due diligence mode. So the first thing we do is estimate the forest extent that we see by aligning, the definition. So for East Kalimantan, they use 30% 5-meter height and 6.25 hectares of minimum area. So we align our data, our CIDR data to that and look into the methodology. So the methodology for East Kalimantan is using Landsat analysis ready data augmented by spot data and manual interpretation of it, which is later on validated by field verification. Whereas our method is wall-to-wall remote sensing, machine learning driven, and later on like sample-based verification. So the methodologies are different, but we use the same remote sensing data, and we can see 1.7 million hectares of more forests within East Kalimantan at the start of the monitoring period. So this can be due to the reason that Ricardo explained, because our models are tuned like for these areas and they detect more forests. And maybe it's due to the methodology, we don't know, but this by itself does not tell us that this is the source of the discrepancy. So we look further. So we look into the activity data that's available to us. Unfortunately, the geospatial data for the activity that was used like to derive, the report was not available to us. So we just took the numbers and plotted them. So this is an aggregate deforestation numbers that we got. So it cannot directly be related like to the emission trends, total emission trends that we show. But it's clear to see that the deforestation in 2020 and 2021 dropped dramatically. And this can't be substantiated based on satellite evidence because we use satellite images to derive our activity data. So in 2020, we can see the jurisdiction detects about 5,000 hectares, whereas we detect 6 times more. That is not substantiated by satellite data. So this can be a source of an issue or the source of the discrepancy. So to complete the due diligence, we also look into the carbon accounting. So methodologically, there's clearly a difference because the jurisdiction uses forest inventory plots and uses IPCC standard equations and constants to derive the emission factor, whereas we use biomass time series into before and after deforestation to quantify the carbon stock in a especially explicit manner. Then we can track from a specific forest biome transition to deforestation, say agriculture or pasture and so forth. So based on this, we compared the one that I show on the screen is dryland forest transition to non-forest. And remarkably, the emission factors aligned. So FCPF estimates 484 tons of CO2 per hectare, and our remote sensing-based approach gives 508. So clearly, this can't be the reason of the discrepancy that we have seen earlier. So based on all the information that we had, we put the East Kalimantan jurisdiction at medium to low because the activity data discrepancy is not accounted for based on the information that we have. So I want to be very clear what I mean when I show like this rating and this spectrum. This means based on the information that we have not accounted for the discrepancy. We are not saying the credits are bad, or we're not criticizing the jurisdictional report. So now we go into a different part of the world, to Côte d'Ivoire, as our next case study. So Côte d'Ivoire, also like East Kalimantan, has been experiencing a lot of forest stress and forest loss due to expansion in cocoa, logging, and smallholder agriculture. And there's also a few projects and a jurisdictional REDD project registered under FCPF within this jurisdiction. And instead of like looking at the whole of Ivory Coast, we selected 5 jurisdictions in the southwest part of the country. So the first thing we do, like in the due diligence, as I explained earlier, is look into the emission reduction trends. So here, the trend that we have seen is flipped from the one that of East Kalimantan. We estimate higher emission reduction than what the jurisdiction is saying. So this is also a discrepancy. So we try to look into the emission time series from the start of the historical period. So here, clearly, you can see a clear trend. Reduction has been happening consistently until 2024, but the emission we estimate is much higher than what the jurisdiction is reporting. So we also go into due diligence mode to understand like what is causing this. So we align our forest definition now to 10%, 5-meter height, and 0.1 hectare. That is the jurisdiction definition. So we produce outsider data now based on that. We adjust outsider data based on that definition, and also look into the methodology. Here, our methodology is wall-to-wall remote sensing based, whereas the jurisdiction estimates its area based on sampling. So we detect around 0.8 million hectare more forest. So this tells us maybe it's a methodology difference. Maybe it's because we do wall-to-wall remote sensing, we detect more forest. So this may lead to more emissions because we have more forest and we look into more deforestation, or not. So we have to look into the activity data to determine that. So when we plot like the activity time series, we have higher detection, but the trend is more or less aligned. So to adjust for methodology, we adjust our map area by sampling to a sampling-based area. And we can clearly see then deforestation drops to a very remarkable value. For example, for FCPF in the monitoring period was 12.5 kilo hectare, and our adjusted area drops to 12.7 kilo hectare. This is like a 200 hectares difference, which is remarkably close. So we can deduce that the difference was caused by a methodological difference, wall-to-wall versus sampling. So to be thorough, we do the emission factors also comparison. They used plot-based inventory plots, IPCC equations. We use remote sensing based. And when we compare transition from mesophyll forest to non-forest, the emission factors are also remarkably aligned. So this tells us carbon accounting is not an issue. The problem, the source of the discrepancy was methodological, which could be explained. So the rating goes high for Cote d'Ivoire because we can explain the differences. Now I hand it. So finally, the key takeaway, like from these case studies that I have shown, is by doing jurisdictional alignment, we can generate independent monitoring that is essential to distinguish activity data inconsistency, that is other reasons, from explainable methodological differences. So all of this, when it comes together, it helps us understand what is happening within the jurisdiction and provide more confidence in the submissions. So now I hand it over to my colleague, Raymond.
Thank you, Adugna. So by now you've heard from our amazing scientists, Ricardo and Adugna, to give you a deep dive on the science behind our JREDD solutions and how we conduct in-depth deep dive comparative studies across countries and jurisdictions. So let me close by pulling the lens back slightly. So everything you've heard today, from the market to our specific solution to the science behind these data and solutions to the due diligence work, really comes back to one simple idea, that we can't protect what we cannot measure. So to make JREDD programs credible, scalable, and investable, we believe that the whole ecosystem really needs transparent and comparable data, so that this can be guided, the investments can be guided with very informed decision making from the jurisdictional governments, from the NGOs and international organizations that are supporting them, and from the private sector that are partnering with the jurisdictions to make these investments. So if we think about it across this whole value chain, so a country that's building these JREDD program needs solid activity data mission factors to build this program in the first place. And we work with countries and jurisdictions directly, as well as coalitions such as GCF Task Force, to exchange data and insights and provide our data for comparative studies and supporting countries in their forest policies, from wildfire to illegal deforestation to jurisdictional program. And we also partner with standards and registries so that new innovations and data sets can support the development of new methodologies, such as VM48 from Verra, as well as upgrading existing methodologies so that it reflects the latest science and innovation, and that they can get these programs ready for issuance at a timely manner. And finally, investors and buyers will need independent due diligence, so they can know what they're paying for, on the ground. So when you look across all three, you realize that that is the role that we hope to play in partnering with actors across this ecosystem to provide independent, scientific, transparent, and comparative data and solutions that can help grow the market together, so that we can grow from 1 or 2 jurisdictions to a dozen in the next 5 years, so that we can increase the pipeline of credit issuance to hundreds of millions of tons of CO2 equivalent on an annual basis, and mobilize billions of dollars a year for JREDD market. And with that, thank you so much for your time, and we'll open it up now to audience Q&A.
Thank you very much, Raymond, and also Ricardo and Adugna for your presentation. I also want to say thank you to everyone who's weighing in the chat and the Q&A. We have about 15 minutes, so I'm going to be moderating and going through as many questions as I can. So I'm going to turn first to Ricardo with a question about the differences in monitoring forests versus other ecosystem types like wetlands, dispersed trees, dry versus humid forest. Can you tell us a little bit about your experience as you've been conducting this JREDD analysis?
Yeah, So the areas that we are monitoring here are not necessarily the individual trees that you can find on a pasture. They are areas that meets the forest definition of a given country. So that we apply the forest definition of the country when we are calibrating our maps. So for example, I think maybe that relates to a question about the accuracy and certainty over like America. Like we calibrate the data to the jurisdiction and to the forest that exists on that jurisdiction. So the case of America, for example, the higher uncertainty you may see there is because they're very challenging. Like a lot of the jurisdictions in there for those assessments were states from the Cerrado and Caatinga environments. So they are savanna covered and semi-arid environments. So they are very seasonal. They are shorter trees, and for a long period of the year, they are not very green, right? So they are much more challenging to map and to find the changes. So that's why you may have differences in the accuracy and the uncertainty over those. Does that cover, Daniel?
Great, thank you, Ricardo. We had another question about the interaction with the jurisdictions. So I'm wondering, Adugna or Ricardo, if you'd like to share a bit more about how you've engaged with jurisdictions as you've developed the analysis.
I can go, Adugna, if you want. We have had talks, meetings with a few jurisdictions while we were doing this due diligence for jurisdictions we have analyzed so far. It's been like an exchange of information. The jurisdiction, the government, they're often need to use the official data for their assessments, data from their FREL, from their greenhouse gases inventories. So a lot of times those data are not necessarily designed for this kind of assessment. And then the jurisdiction sometimes find that they need to adapt or they need to do something. And a lot of times they're tied to the official data sets. And then it may be challenging to get, in my opinion, the most accurate results. As the example I showed for Mato Grosso, the state of Mato Grosso, for example, when it does its own estimate, if it uses only the TER, it's gonna underestimate. So, but in another example, Tocantins, for example, they were clever and they incorporated other kinds of data set from Mabiomas, for example, fire, which is not official data set, but they understood that they needed to add other data sets to complement the official. So I think these exchanges that we are having with jurisdictions, it's that kind of like level of exchanging scientific information, the method, the data, and to try to arrive at a consensus in the end. Like, is the state reducing? Yeah, that's what we want, right? We want the state to be reducing deforestation, but then at the end, the people that are gonna be paying for that, the buyers, right? They are interested to that their money is gonna be well invested, right? So we also want to support those players so they can invest and have a credible number and estimate and certainty around what they are investing into.
Great, thank you, Ricardo. And I think one point of clarification is the analysis that we shared was conducted on behalf of a buyer who's interested in independent due diligence reports. But as Ricardo noted, that process involves engagement with some of the jurisdictions. There was a question about the cost of shifting to annual MRV. And I'm interested, Adugna or Ricardo, if you could share an insight about how jurisdictions can engage or access annual monitoring solutions.
Yeah, so some jurisdictions like Brazil, they are more advanced in the satellite-based monitoring of forests. They have history of doing that. and great data sets such as PRODES and DETER. But other jurisdictions, they don't have great space research institutes. They didn't have time yet to evolve into that. So they may use still methods that may be a little bit outdated or have those uncertainties that I mentioned. And maybe they did not reach yet the annual monitoring, the best what science can do. So what we try to say here is not that we want to bash and say, okay, they're all wrong, right? We want to point areas that the data can be improved, right? And we are available to also help those jurisdictions. It's part of CTrees' mission as well, in terms of capacity building. So if you're also part of a government jurisdiction and you're looking to building your own MRV system, let us know and we can help, because the annual mapping, like as one example, is really important, but also can be very overwhelming. It's a lot of data. And a lot of data needs high processing computing. Like just an example, the pantropical data is more than a petabyte of data. It's so much data, so it can be very overwhelming. And we can help with that. So reach out. Yeah.
Great, thank you. I want to come to a question about confidence levels. There was a question about how we address uncertainty, and I know, Adugna, you introduced this idea of the kind of confidence spectrum. Can you share a bit more about how we think about uncertainty at CTrees?
Well, you have to have like high quality data, right? Like to have a credible comparison. So if your uncertainty is very high, that means your data or the jurisdiction's data is unreliable. So comparison would be meaningless in my opinion. So unless we get like more information to elaborate and clarify and compensate like for this high uncertainty, we will put it at a low confidence level. That's what we've been doing in the past.
Great, thanks, Adugna. We had a question about how CTrees estimates emissions. Are we incorporating ground-based field data in its estimates? Are the estimates derived purely from remote sensing data? And how important are allometric equations in estimating? And what are some of the differences in estimating emissions across different forest types and ecosystems?
I can start. If Adugna wants to complement, you can chip in. The AGB data set that we use is the basis for the emission factors that we calculate. So it's the AGB time series from 2025, released by CTrees last month, openly available. That data set, it's based on remote sensing data, and it uses the field data inventories to calibrate the modeling approach, right? So, like for example, I can say, because I help to get access to that data, it uses the Brazilian National Forest Inventory. So whenever there is data available openly that we can download and include in these estimates, we are gonna do it. However, a lot of cases, what we see, and I think this was actually not mentioned enough in this presentation, jurisdictional data is often not open. That's the truth. I can go in. We did a quick research recently for all our trees and FCPF data. Out of like close to 40 jurisdictions, not all of them have reports, but we got access to the actual data for less than 10. So it's a real challenge to get the data on your hands to be able to use it. So the global data sets that we build are based on the data that is openly available. We can, of course, recalibrate the data for a given jurisdiction, and we compare the emission factors that we calculate with the reported from FCPF or CTrees. And if there is data available for that calibration, we are gonna use it. So I think that's the gist of it.
Right. Thank you, Ricardo. We had a question about who is paying for independent monitoring, um, uh, and whether the jurisdictions have access to the data. Raymond, would you like to address this question?
Yes, thank you so much, Daniel. And first of all, thank you everyone for your time and interest in our webinar. And thank you again for your enthusiasm in asking these amazing questions. I want to first acknowledge that we may not be able to have time to answer all of these questions. And so we will be focusing on answering questions that are relevant to the JREDD Plus programs. But if you have other questions about specific technical approaches as well as our other data sets innovations, feel free to follow up with us after the webinar so that we can respond individually to your questions. And thank you, Rosalind, for this great question. So for us, this all comes back to one goal, which is where I closed the webinar, that is growing the market. And growing the JREDD market and programs really, to us, mean two things happening, at once. They can happen in different sequence across different jurisdictions. First, it means more jurisdictions building strong jurisdictional programs and actually getting them across the finish line, meaning getting the credits issued. And second, it means that investors are looking at these credits and knowing that they're funding very important nature-based solutions and that the JREDD credits are valuable, high quality, and worth their investments. So these two are where we see independent monitoring earn its role. And they're sort of the two sides of the same coin. So on jurisdictional side, we hope that we can help countries, build a robust program. So this means providing the data to the countries to help them with the Verra analysis, to help them with the UNFCCC submissions, and building the foundation for a jurisdictional baseline and calculating the emission reductions, as well as accompanying their existing data sets to support their validation process. So on the investor side, that means give the buyers a read on what their investments will be, what they will be investing in, and so they can put their capital in with confidence. And if we look at it from that way, then it is clear that the jurisdictional program is best supported through dedicated TA, so technical assistant work. So that means funders, countries, and multilateral, which can keep the program moving in the early days. And the investor confidence work is likely going to be funded by the buyers themselves, so that because they're the ones de-risking their large investments. The encouraging part is that we see independent data playing a role on both in both directions. But in this case, we first and foremost need to respect the sovereignty and the choices of individual jurisdictions. So depending on if the jurisdiction actually has a need or they already have very robust solutions themselves, and then we only play a complementary role in how we can support the jurisdictions. So we don't want to assume that we can support every jurisdiction in all the ways that we listed here, but we complement the jurisdictions in specific ways that they will need, whether that's building the program, getting the program, ready and getting the credits issued, or attracting investments, from buyers and investors.
Thank you, Raymond, for that response. I know we have only a few seconds left at the top of the hour, so I want to thank Raymond, Ricardo, and Adugna for your presentations. Thank you, everyone who has joined. And we also want to make sure that you can reach out to us You can email us at info@ctrees.org. My colleague Rachel has shared a link to our contact form in the website. If you're interested in working with CTrees on jurisdictional REDD, whether you are a jurisdiction, a buyer, or a standard or another market stakeholder, we'd love to hear from you. And as Raymond emphasized, this is about supporting the market and making this important nature-based solution available broadly to have impact on protecting forests globally. Thank you again to everyone who has joined, and we look forward to hearing from you soon.